Now, in our second example here, we have a few more problems. Instead of having simple plus 5x and plus 6, we now have minus 5x and minus 6. So when we have a negative number in the middle, we'll be needing to think of factors that will contribute negatively. And when we have a negative third term, we're going to be looking for one of the constants to be negative and one of the constants to be positive. So there are a number of ways to think about this, but typically I tend to think of the overall magnitude 6, that two things multiply to 6 but have a difference of 5. And in this case, they multiply to negative 6 and have a difference of negative 5. So let's think of things that we can multiply together to get negative 6. And there's negative 6 and 1. There is 6 and negative 1. There is 3 and negative 2, and there is negative 3 and 2. And I would like to have it when I add them that I will get a difference of negative 5, and it looks like this should be our pair here. So let's test that to see how the logic works. That would mean that we would have x minus 6 times x plus 1, and we can test to see if that works. We're hoping that's equal to 0. 6 times x is going to give us negative 6x. That is, negative 6 times x will give us negative 6x. X times x gives us the x squared term that we wanted. Negative 6 times 1 gives us negative 6. And x times 1 gives us x. And I'm purposely kind of doing it in any order because it doesn't matter. As long as at some point I've distributed each term onto the other, that should be in good shape. And let's see how we did. This gives us x squared. Minus 6x plus x is minus 5x and minus 6. So that worked just fine. And what that means is that we know, since this is the factor, this is our a times b factors, set equal to 0, that either a, which is x minus 6 equals 0, or b, which is x plus 1 equals 0. So the two solutions we will have for x are going to be that x is equal to 6 or x is equal to negative 1. So here's the final factored version of it, and here is the solution for when we see a problem that looks like x squared minus 5x minus 6 equals 0. In our third example, we'll take a look at the most complicated possible factoring situation for a quadratic, and this is when there are coefficients on each of the three terms. Now we're in general again looking for factors which will give us, let's see, we need whatever is on x here, we'll need to multiply on whatever is x here to give us 6. So possible things that would do that could be, we could have 6 and 1, we could have 3 and 2. Those would be possible things we could have. I suppose we could have negative 6 and negative 1, but usually if you end up thinking of both of them as negative, there's a simpler version to be had. Now let's see, that means that we now have the end of the terms here, whatever is at the end of these two binomials needs to multiply to negative 3. So some possibilities there are going to be negative 3 and 1. Of course, I could have had it the other way around, so it could be negative 3 and 1. And I could have had, well, that's pretty much about it. So now I need to think of combinations of these multiplications which will turn into additions that will give us negative 7. So we could test it out a little bit. Some options for our problem right now look like 6x minus 3 times x. We're taking this first pair here and this second pair there, plus 1. We can see how that works. So here's maybe case A, case B, and case C and case D. So let's see, that was case A with case B, or sorry, C, And we could have had the other way around, right? So we could have had 6x minus, 6x plus 1 times x minus 3. That was another possible thing that could have worked for our first and last terms, but we don't know which one's going to give us the satisfying result for the middle till we test it out. Then we could have also had 3x minus 3 and 2x plus 1, or we could have had this other version, so it could have been 3x plus 1 and 2x minus 3. So those would appear to be the four options that we have, and what we really need to do now is to test to see who's going to give us that negative 7x in the middle. Now if I take this first one, we'll call this case 1, 6 times x is going to give me 6x squared, which looks good. Then 6x times 1 is 6x, so I'll get 6x there. Then minus 3x, that would be equal to 3x. Well, that's not what I want, so I know this is not one of my considerations. Problem 2, then we have 6x times negative 3, which is negative 18x. Already seems like it's way too big. And then plus x, that gives us negative 17, so that's out. And our third possibility here, we have 3x times 1, which is 3x, and then we have negative 3 times 2, which is minus 6x, and that's only negative 3x, so that doesn't work, so let's get rid of that one. And we're hoping our last one works. So 3x times negative 3 is negative 9x, and then 1 times 2x is plus 2x, and that total is negative 7x. So it looks like this is our solution. And let's take a look at that and see if it makes good sense. So we have 3x times 2x, which is 6x squared. We have 1 times negative 3, which is negative 1. Of course, we knew that would work. That was how we picked all of these ideas here. And then we really just had to test to see if the linear terms, the terms with just an x on them, so 3x times negative 3 and 1 times 2x would give us a total of negative 7. And finally, let's check to see what our solution is. So we know that 3x plus 1 times 2x minus 3 is the same as this trinomial here, and this is being set equal to 0. So let's make a little space for this now. So 3x plus 1 times 2x minus 3 is all equal to 0. So again, here's our a times b is equal to 0. So either 3x plus 1 equals 0 or 2x minus 3 equals 0. And that means that x is going to be equal to negative 1/3 or x is equal to 3/2.